I just pray that this time around it will be fine. I'm so sorry. Network is having it worse tonight. I want to believe that. Okay, sorry about this. Um, good evening, guys. You are welcome. Uh, my network was still booting then. Sorry. I think so. We'll start. We don't have time. So don't forget before you open your chat, give the video a thumbs up. It's very important. Thank you. So we stopped on examples of algorithm. We've uh, dealt with the meaning of algorithm, the meaning of flowchart, symbols used in flowcharting, and then we are currently on examples of algorithm. And here are the examples we'll be given. An algorithm can therefore be seen as a step-by-step method of solving a problem. That is a valid one. Let us just use this one to refresh our brain and to start this section. This section may last very long if network permit. There's a tendency of being here for the next 3 hours. And then we leave the rest to the hands of God and luck. So, examples. Write an algorithm to read values of 3 variables, u, v, and w, and find a value for result from the formula. Result is equals to u plus v squared over w. Draw the flow chart. Then in solution, the first thing is you must input your variables. Input is the first thing. After you input, then your computer value for result, you print value for result and stop. Of course, you know that in between input and computer value for result, there is processing. So the flow chart for that problem, you start input u, v, w, where all this one they won't ask you actually. And then because the exam is not drawing. So suppose you are given 20 numbers, prepare the algorithm that adds up these numbers and find the average. Then draw the flow examples. But in case you are asked in the exam to find the result, let's see the result now. Okay. Okay, results is not here. Okay, those are examples of algorithm, mostly step-by-step procedures to follow to solve a particular problem. That is all you need to remember. So even if they cite an example and ask you if it's an algorithm or not, if the example is looking like a step-by-step procedure for someone to follow to solve a problem. So the next thing we'll be doing is pseudocode. That is the last thing under this algorithm flowchart of a thing. We'll be dealing with pseudocode, and it's very good you know the meaning of pseudocode. Program design or a program design aid, a program design aid that serves the function of expressing the detailed logic of a program. There is one question in that your TMA too. I think in this unit alone, we've answered 3 questions. One of those questions asked about something to be used instead of a flow chart. All you need to know about pseudocode is that pseudocode are just like a synonym for flow chart. Let's just say it like that, at least for you to be able to remember. So when you see tomorrow, which one can be exchanged for uh, a flow chart? It is pseudocode they're asking you. Or what can a pseudocode be exchanged for a flow chart? Sometimes a program flow chart might be inadequate for expressing the control flow and logic of a program. By using pseudocode, pseudocode can do more. It can do more than flow charting. That is one thing you should know. Program algorithm can be expressed as English language statement in pseudocode. So if probably you were to be tested on this, uh, I think somebody is asking a question. I'm trying to read that question. Is it that you wait? Oh, I hope you can hear me and you can see my screen because I'm seeing a question. The question is not clear. Your question is ambiguous. Don't forget that in a pseudocode, it has to be unambiguous because the meaning of unambiguous means it has to be precise. Not that you will ask me and I'll start thinking, is it this you are, is it this thing you mean or is this thing you mean? When there are kind of confusion or many options to think about, that is both as a guide. Learn the spelling of sudo. Don't go and be doing exam tomorrow and go and be writing sudoku. Like I know some of you will be funny tomorrow when it comes to spelling. Learn the spelling of pseudocode very well tonight. Don't go and be using your mother's tongue to spell it tomorrow. All right, so and it is pseudocode that uses English language statement to represent the processes involved. So because there is no rigid rule for constructing pseudocode, the logic of the program can be expressed in a manner without confronting any particular programming language. A series of structured words is used to express the major program functions. These structured words are the basis for writing programs using a technical term called structured programming. Structured programming. Okay, at least all you need to know in order to remember pseudocode tomorrow is that they are used interchange, like you can use them instead of flowcharts, and they can perform more functions than flowchart because they are written in English words, not in diagram like flowchart. Look at example of a pseudocode. Construct pseudocode for the problem in the example above. Well, they didn't give any example, but this is an example of the solution using pseudocode. Begin, store 0 to sum, store 1 to count, do while count not greater than 10, add count to sum, increase count by 1, end while, end. That is pseudocode. Another thing we'll be looking at is decision tables. Decision tables are, well, all of you writing pseudocode. That is not correct. All of you writing pseudocode, that is not correct. That is why I intentionally cut out that word there. It is not pseudocode. It is actually pseudocode, but not the plural. Sorry, not the singular. It is the plural form. Are you sure you can't hear anything? Somebody is saying that you can't hear anything. I think it's from your side, please. You can leave the meeting and join back afresh. Okay, so let's continue. Decision tables. Decision tables are used to analyze a problem. So the work of decision tables is for the analysis of a problem. When you want to do analysis on the problem, you use decision table. So you guys should correct yourself on that last question. It is pseudocodes. The S is there, not just pseudocode. And I think decision tables are used to analyze a problem. So that is that. The condition applying in the problem are set out and the actions to be taken as a result of any combination of the conditions arising as shown. So blah 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 decision tables. Okay. Okay, I think what we are listing now is not just is it hold on. Those are things we use in hold on, let's get back to that in structured programming. You have decision tables. That should be the first one. Okay, no, sorry. In decision tables have standardized format and they comprise of 4 sections. When you want to use decision table to analyze a problem, it has 4 sections that you can use, 4 resources available for you to use in the analysis using decision table. So we'll talk of the 4 of them now, so that in case they list 3 in options tomorrow and ask you to fish out one that is not part of them. That is the first one. And the meaning of the condition stop is this section contains a list of all possible conditions which could apply to a particular problem. Don't forget that the decision table is used for analysis. It first presents all possible solutions to that problem. So in that regard, the section of it that deals with presenting all possible solutions to the particular problem to be solved is the one we call conditions stop. Then we have the condition entry. This is a section that contains the different combination of the conditions, each being given a number or a term, a number termed rule. So the condition entry is where you set the rules, that must be followed by the different combination of possible solutions that you have, or possible conditions that must be satisfied for that problem to be solved. So the condition entry is where you set the rule that okay, maybe this must be combined with this, or this is going in first, or this is coming in first. So that is the condition entry. Don't forget, you start with condition stop, condition entry, and then the action. Action stop is also there. This section contains a list of the possible actions which could apply for any given combinations of condition, which means when I combine this condition and this condition, this is the result it will give me. That is action stop. Like it's just like assuming you are compiling arithmetic and you are saying if you say minus multiply by minus, it will give you plus. Minus multiply by plus will give you minus, and then plus multiply by minus will give you minus. So when you have those are conditions. Those one like that, you can store them in condition stop. Then when it comes to applying it to a particular problem, like using it in board maths now, the one that will come first, the one that will come second, maybe that is the one you put in condition. That kind of setting is done in the condition entry. So the condition that goes in first or that apply first. Then the action stop is when you do minus multiply by minus, the end result will give you plus. So the action is you multiplying minus by minus and you getting plus. All those conditions, the actions that will result by combining minus times minus will be stored in the action stop. But we have one final one, which is action entry. What we have there, we can just say there are two. One is the The other one is the entry. So condition stop, as in let's just say condition stop also means condition store, where you store conditions. Then condition entry, when you start applying them. Then we have action stop, where you store actions, you understand, and action entry, when you act, when the actions are put in place. So action entry, this section shows the actions to be taken for each combination of conditions. So I think we have done justice to this part. We will soon go to what we call conclusion. Okay, I have a question here. Good evening, Dora. Good evening, everybody. Sorry, my manners. I think the network made me forget to greet everyone. You are all welcome. You are all cherished. You are all doing well. Don't forget to give the video a thumbs up. It's very important. Thank you. And those of you that used to dash me money, thank you. Now you make me go buy fuel now. If you no dash me money now, I for no buy fuel, for no do class, no light. Okay, so action stop. This section contains a list. Okay, we've done that, and then action entry. In other words, in decision tree, decision tree which is used for analysis, we have 4 sections. We have the condition stop, condition entry, action stop, action entry. Very simple to remember. So in case tomorrow they likely want to test me on this part and they added one of it, maybe they asked maybe something like action stance or action something that is just not part of it. The major thing is we have 2 things here. One is entry, one is stop. The 2 words they added to them is just condition and action. All right, let's read the last part and move from this place. Writing the instructions in a, which is program coding. The instruction contained in the algorithm must be communicated to the computer in a language it will understand before it can. The first step in writing this instruction is the programming language, which is also known as the program coding. Those of you that are coding, you understand this. You see, this course is actually sweet for those that are in the computer science, information technology, or any science department. Seriously, it's actually going to be interesting tomorrow. You guys, you just be laughing, but those of you that are in the art class, God is your strength. Oh, hey. So that is it. Program coding is the process of translating the planned solution to the problems depicted in a flowchart, pseudocode, or decision table in statement of the program. Now, after you design the solution that you want to use to solve the problem, either using algorithm, either using the flowchart, the pseudocode, or decision tree. In other words, what I just telling you that flowchart, pseudocode, and decision tree, they are all methods of drafting your way of solving a problem. That is what they are saying now. So flow charting, pseudocoding, and decision table, they are all methods. They all evolve around the method of drafting, designing the solution to the problem you have on ground, coming up with the logic that you will use to solve it. So coding is now a way of putting them into action. Program coding is the process of translating all the designs you've done to getting the problem solved using either flowchart, pseudocode, or decision table into statement in the program, or statement of program, which is what programmers do mostly. That's how we call them programmers. So the program flowchart, pseudocode, decision table, as the case may be, is a guide by the programmer as he describes the logic in the medium of a programming language, usually done on coding sheets or coding forms. So these are things we ignore, and you now see that is what they'll be asking. So let's not ignore anything. I have a very short classwork. I want everybody to contribute. It's a very short one, but everybody contribute to that. That is a question. The coding is usually done on Dash. Okay, in conclusion to question whole thing we have been reading, it all came from just one TMA question. The question asking about algorithm. Flow charts. I hope you guys are seeing that if you are reading with TMA question, it's actually before you know you have covered your material. Flowcharts, decision tables, pseudocodes, and algorithms are essential ingredients to the writing of good programs. If they are done properly, they lead to the reduction in errors in programs. They help minimize the time spent in debugging. In addition, they make logic errors easier to trace and discover. In summary of this unit, while you guys are answering that question, let me give you summary. Amaka, Mary, Cynthia is not coding sheet alone. The answer is in two forms. Those of you writing sheet, writing coding sheet, that is not the correct. The only person I've seen that have given me something reasonable is, I think that is Fatima Koladafe. You are correct. Khadija Mustafa is also saying sheet or coding form. That is correct too. Big Eniola, yes. Okay, I think some people have given me the correct thing earlier. All right. So, in summary of this unit, a flow chart is a graphical representation of the major steps of work in process. It displays in separate boxes the essential steps of the program and shows by means of arrows the directions of information. Decision tables are used to analyze a problem. Don't forget, the conditions applying in the problem are set out and the actions to be taken in four different forms, which is the condition stop, condition entry, action stop, and action entry. Then the pseudocode is a program design aid that serves the function of a flowchart in expressing the detailed logic of a program. That is a pseudocode. The last one, an algorithm, is a set of rules for carrying out calculation either by hand or machine. Haven't done that, we are done with this unit. So I think we can go to question 3 now. We are good to go to question number 3 now. Question 3, question 3. Okay, so let's test ourselves once more on this, what was it called? Just one more time. The question that led us to that algorithm of a place in the material. So what is the correct answer? Everybody contribute. I don't want to hear somebody have mentioned what I want to say. Okay, question 3. Now question 3 will lead us to another part of the material. It's talking about touchscreen is an input device. Oh, sorry, it's a dash device. Okay, this is the next question, and this is the next thing that will lead us to reading. And what it's going to lead us to is probably to read about the input output system. So let's see where we can find touchscreen in our material and then read all about that part. You generally wouldn't be reading like this. If you want to read, you would have started from okay, I think I will need to use touch. Probably we can say uh what can we use there? Trying to get another logic to use. Input output devices. Okay, input output devices. I think the input output is in that unit 1. Yeah, sorry, that mode 1, the very beginning of this material. Let's go there and read a bit about it and summarize. I think this place we've done it before. Be reading the full detail. We'll just summarize, just to give you guys the tip and help you to understand. There are other places we need to go. So Let's start. Okay. All right. That is the basic concept of the computer, the definition of the computer, understanding data processing, the concept of data information, method of data processing, characteristics of a computer. Now, computer is fast becoming the machine of the 21st century. I think you guys know that already. Early computers were large in size, too expensive, and only specific individuals were able to own them. Not like now that everybody's getting a laptop, a desktop you like. Well, computers are used for solving both scientific and engineering problems. Please, you should note that computers are used in solving both scientific and engineering problems. So we need to define a computer, understand data processing and the rest of them. Well, a computer is basically defined as a tool, like you guys already know. This part I will just be summarizing. Like I know we've done it in full. I will dwell so much on it in that video. So let's not waste time. A computer is basically defined as why is this one going up and down like this? Please hold on, let me get it together. Okay. A computer is basically defined as a tool or machine used for processing data to give required information. This one is not even something you cram, because when you see the definition tomorrow, probably it come out. You should know that it's a computer, a machine or a tool that accepts data and processes the data and probably give out, or not probably, eventually gives out the required information. That is a computer. And what are the things a computer is capable of doing? It's capable of taking input data through input devices like your keyboard. Okay, a classwork. Mention all the input devices you know. Yes, yes, in the chat box. Mention all the input devices you know. Keyboard, yeah, mention the rest. Input devices you know. Because that is how some of you will see scanner tomorrow and you can be saying it's an output device. It's better scanner when it comes to this part of the listing. Basically, something they focus on. So is a scanner an input or an output or a processing device? So the computer is capable of doing some things basically. One of them is put through the keyboard and all input devices. After it takes the input, the next thing is it stores the input into a disk, and after that, it processes the data in the CPU. What's the full meaning of CPU? There is a question in the TMA. The question is a blank space. I okay. Let's see. I don't know that question. There is nothing we write there that they marked it. When you write central processing unit, they mark it wrong. When you write the brain, they mark it wrong. I don't even know what they are actually expecting as the answer to that question. I'm still trying to look for the answer. But in any case, everything that has been written there has been marked wrong, or probably it's just an error, a bug. So storing the input data into a disk and then giving out the result output on the screen. Well, let's use something very simple to relate to this so that tomorrow, at least if you can remember each of these characters or each of these capacity of a computer, what the computer is capable of doing, you shall remember this illustration. Consider it like yourself attending a class. When you attend a class and you listen to the lecture, the process of you accepting, or sorry, listening and receiving what the lecturer is saying, you are taking in data through your ears. Your ears now serve as the input device. Your eyes that you are using to watch the illustration or whatever the person is writing is also an input device. When your eyes and your ears take in the data, it goes to your brain actually, where you decide to store important information. You understand? So the input device accepts it. It goes to the storage. The storage stores it in your brain. Your brain, just like the computer is having diskette, hard disk, and other medium, RAM and ROM and the rest of them. The same way your brain too, you have the long memory and the short memory. So if it's something you will need for exam, you may need to put it in the long memory. After you store it in memory, by the time you go home, or probably you are preparing for exam and you start revisiting them in your brain to start processing them, or it's not even time to process. In the exam hall, when you need to start bringing out the things you've read or you've actually learned from the classes or lectures, what is happening in your brain now is processing. Your brain is processing all that you have heard concerning the course that you are writing an exam on that day. So it will do the processing in the brain too. The brain, there is a part of the brain for memory, there is a part of the brain for processing. So it processes. If a question comes, it goes back to your memory in your brain there and try to figure out if there is anything there that relates to that question. You understand? If there is anything, the processing takes place and then it gives you the result, which is the answer to the question, and you write it down. What you are writing down now is not an information, the result of what of the processing that has taken place in your brain. So that is what the computer does. It accepts data as input, it stores it, it processes it, and it gives out result as output. And the output can come out in any form. What's the full meaning of VDU? I know some of you that like television, you would have seen it on your television before. What is the full meaning of VDU? Even though you may not know the meaning. So what is the full meaning? Means what? So that's a short classwork. And this is a schematic diagram of what we have just explained. So what is data? We say that the computer accepts data through input devices. What is that data? Data is a term that refers to facts about a person, object, or place. So any fact about anybody, about any object or any place is called data. And information is referred to as a processed data. It's as simple as that, a meaningful statement. Information is a processed data, a meaningful statement. For instance, if you get your complexion as fair in complexion, well, if you just, while you are trying to, we get that complexion is fair. So if I want to give out the information, I will say that Dora is fair in complexion. That is information. Well, I'm just getting Dora's complexion. For me to write complexion fair, that one is data. Whose complexion is fair? Now we'll come to say Dora is fair in complexion. All right, so that is all on data and information. We've done this before. I don't want to waste time on it. We have a lot. Methods of data processing. We have three of them basically. We don't need to even waste our time here. We've done the reading before. We have three of them basically. We have the manual, we have the mechanical, and we have the computer method. The manual method is the one that is totally dependent on human effort. Human are the one that, it's just like when when they were using all those stone age, everything then was all manual method. Manual method of doing things, manual method of processing things. When you are in the manual method, that is when you use your pen and your pencil. Please, in case anything come out on this section tomorrow, the manual method is when you write on paper, you use your pen to write. Like now, if you go to a lecture or a class with an exercise note and a pen, the method of uh, data acquisition you are using there is that you are writing the data or the information being given in that lecture, you are writing it down on the pen, sorry, on the paper using the pen. You are using manual method. Then your friend in the same lecture, you see someone else came with a typewriter or a typing machine. That person is using mechanical method. The use of machine in aiding data processing, in aiding the processing of our activities, is called mechanical method. Once there is an introduction of machine, now let's compare them a bit. Why the computer method is basically using the computer to process data. So the manual and the mechanical, the only difference between the manual and the mechanical that we can say is that, well, first of all, both of them, human assistance is needed. You understand? But the manual is totally dependent on human energy. Why the mechanical method, the machine will work, but it also depends on human to control it. You understand? One disadvantage you should remember about mechanical method is that they are very noisy. If you have been in a place where they are using typewriter to type, you do pa, 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 the noise is too much. Computer is not like that. If you are typing on your keyboard now, except you are intentionally stabbing that keyboard, or you are pressing it with too much pressure, it doesn't make any sound. So that is one thing about mechanical method. They are very noisy, they are hazardous, because in the mechanical method we have some of them that produce smoke, large amount of heat, and all other things. So they are somehow poisonous, hazardous to the health, and so on. So then for the manual method, is too slow. Manual method is too slow. The mechanical method is a bit fast or faster. And then the disadvantage of manual method is that errors cannot be easily corrected, and they are very prone to errors. You can make a lot of errors when you are using manual method, and they are not easily corrected. The same with mechanical method. Their errors can, well, the errors is a bit on a is not as much as manual method, and but the same thing applies that even in mechanical method, errors are not easily corrected. The only method that guarantees error correction freely is the computer method, because when you are typing a document, all you need to do is delete or backspace, clear that thing off, and of course, write the correct thing you want to write. So that is the idea of the data processing method we have, which is the manual, the mechanical, and the computer method. Now, advantage of the computer method, when you are actually using the computer method, you have an advantage of speed, accuracy. You know, it's, it's flexible, reports are clean, they are neat. So in fact, these ones are not just things you need to cram. You know the advantage you are getting now using the computer to process data. So then another thing which is important to stress in this unit is the character of the computer, the characteristics of the computer. Speed. Now, the computer can manipulate large data at incredible speed, not bli, that is e, at incredible speed, and response time can be very fast. That one is not something they need to tell you, you know. I have a classwork for you guys. Let me quickly type it. Okay, check it and see what's the answer to that. Okay, so what are the characters of computer? We have SAS, that is if you want to use, is it mnemonym or what do you call it? SASRF. So this is it now. We say SASARF. Those are the characters of computer. And what does it mean? The first S is speed. Like, you know, the computer is having an advantage of speed. The first A is accuracy. That is one character of using the computer to process data. Then it has storage. Your typewriter does not have storage where you can store anything. It's not that kind of machine. So mechanical method, no storage. Your calculator, no storage. You understand? Using calculator to solve equations or whatever is also mechanical method. So the second S is storage. The next one, which is another A, is automatic. Then the R is reliability, while the F is flexibility. Don't forget speed, accuracy, storage, automatic, reliability, and flexibility in case you are asked any one of them. I hope. Okay. All right. So you guys are having that. Now the computing system. The computing system is made up of the computer itself and the environment where the it's being used, and the person using it. Everything around the computer is what we call the computing system. Both the computer itself, the person operating it, and where you are operating it. That is all what we combine together to call the computer system. And the computer system is made up of the hardware and the software. The computer system is made up of the hardware and the software. When you go to a place where computer is located, you are likely going to see uh, some major things, both physical ones that you can see there and touch, and then the operation that is ongoing inside those physical ones that you can see and touch. That is the software. Then the hardware is any physical part of the computer you can touch, you can feel, you can relate with, like the mouse, the keyboard, your monitor that is there, the CPU that you can see and think of, that are physical, that you can see. They are all hardware. Yes, let's drop examples of hardware we know. Examples of hardware we know. That is another question for you guys. My screen is off. I think I'll need to share it back. I don't know why that happened. I will share it back. So let me share the screen back. But while I'm sharing, help us to drop the examples of hardware. Examples of hardware you know. Help us to drop example of hardware you know. Yes, the screen will be back shortly. Don't worry. So examples of hardware you know, just drop it. Then we'll go to software. But in this hardware, we have some things you need to learn. What's the full meaning of ALU? What is the meaning of ALU? What is the meaning of RAM? What is the meaning of ROM? In my Gst103, then they asked me the full meaning of, like, is it up to 9 times? I don't know why you guys are not locking in your own. They used to repeat questions, like same question. I was asked the meaning like 9 times. The question repeated like 9 times. I was so happy that day. So happy. You guys should be praying for luck. Let the computer be mad when it's giving you question. So ALU, those are minor things, all those stuff now. One, believe everybody should know by now. And learn the spelling. It's not about knowing that RAM means random access memory. Do you know how to spell access? Is it one S you put? Is it one C or double C or double S? You should know. Confuses one in the exam, even when you know answer. So I think we can move on to other things. To software. We can go to software. The computer software is a series of instructions that enable the computer to perform a task or group of tasks. That is a computer software. A computer software. So let me ask us a very, assuming tomorrow I'm lucky to see this question, will I be able to answer it? The question is right there before you. Will you be able to answer that question? That question is right there before you. All right, so let's move on. Well, that is computer software, series of instruction. Like when you just you went to get a computer today, and then you went to computer village, you got a game package, the installation disk for a game. You got the one for corridor, you got the one for Photoshop, you got the one for music player, you got the one for DVD player, and all those things. All those things are all called softwares. They are already series of instructions programmed that when you install them and you start using them, they will start giving you result by performing some task for you. You understand? They will start performing some tasks for you. You can use Photoshop to edit your photo. You can use Corel to come up with designs and the rest of them. Now you have a task. You are using software to perform the task. That is why they say a software are series of instructions that enable the computer to perform a task or group. Another thing you learn about computer is the computer users. Computer users, sorry, user. I am the computer user. Anybody using the computer is called a computer user. People that operate the computer, that is a computer user. Why the computing environment is everything around the computer where a computer is placed and is being used. The building, the furniture, your table that you place it on, your